All right, so we are back with another deep dive video. So in this video, what I wanted to cover is different chunking strategies for RAG. Now, we have looked into several advanced RAG strategies in this YouTube channel, but mainly the RAG performance depends on how you are doing the chunking. And that is also the thing that is most overlooked when you are building a RAG. So you should give more emphasis on how you are chunking your documents and what is your chunking strategies, because those chunks will be retrieved while doing the RAG, and that will be passed to LLM as a context, and then the final answer would be retrieved, right? So if your chunking strategies are not well defined and which is not meaningful to your use case, then your RAG will perform poorly, right? So we will slowly talk about the different chunking strategies, what are the pros and cons of those chunking strategies. So we will start with like character text splitter, then we will go to recursive character text splitters, and then slowly we'll move into the token text splitter, and in the end we will see like how we can do a semantic chunking, right? So first of all, like why do we need chunking? So in case of RAG, what we generally do is we get the set of documents, and those documents we kind of use any loading methodologies, like with the help of like PDF loaders which are available in LangChain or Llama Index. Then we kind of load those documents, whether they are text, PDF, or whatever the document type is, right? So we will load those documents, then we create the chunks. Now, why do we need to create these chunks? Sometimes these documents can be very huge. Your document size or the chunk size should not exceed the number of max tokens that are allowed while creating the embedding, and it should not also exceed the maximum context length for the LLM that we are using, right? So that's why we kind of create different text chunks, and on top of those text chunks, we create the embeddings. Now, when a user comes with certain question, at first we create an embedding out of that question, and then we do a kind of semantic similarity between the question and the chunks, and then the most similar chunks will be sent back as a context to the LLM to kind of generate a refined answer for the user question, right? Right. Now let's start with the technicalities. So I have taken one sample text. So this text talks about the transformer architecture for neural network in terms of LLM. So this is one of the papers abstraction which I have taken. So you can see like here, the text are like quite well formatted. So you can see like some of the text are like differentiated with paragraphs. So this is like one paragraph, this is another paragraph, and there is a large paragraph, which is the third one, right? Now we will see how we can use different types of chunking strategies on top of this data. You can see like you'll see like the first one starts with a new line, and then also we will see like there are like double new lines which we will see, which indicates that there is a paragraph break, right? So now if I just use a print statement, now it will be like properly formatted, and the paragraph breaks we can see here. That is done. Now let's start our discussion with this character text splitter. So this character text splitter is kind of a very basic of text splitting strategy, but generally people don't use it as much because this is very naive approach, and it does not look into the data structure of the text that we are sending, and it's generally splits the text between using the length of the characters or certain issues which we have if we are using a character text splitter. So it might happen that your words or sentences are even getting splitted into different chunks, right? So which may not be the correct way to create chunks when we are doing a text chunk, right? So at first we can import this from LangChain text splitter, then we can mention the chunk size. So this is the character length which it will consider. So whenever the character length is exceeding the 200 mark, so then it will create a new text chunk. So I am mentioning the text overlap as 0, and then I am mentioning this separator as this. So this is a separator for a character, right? So if you don't use a separator, so by default it uses paragraph or double slash n as a separator, which will give you certain garbage values if you are using it. So better if you use, if you're planning to use this character text splitter, you use this separator. So once that is done, you can like start creating chunks out of it. So you can see like at first it created 10 chunks, and these are like each of these chunks looks like. So one of the thing that you should be mindful of here, that if you are using this create documents, you need to pass your text as a list, right? So that's why I'm passing this in terms of list, my string character, which is string document, which is present in this text variable, right? After that, you can like go through and loop through each of these chunks, and you can see like what are the length of each of these chunks. So the first one is like 199. So each of the chunks are kind of less than or equal to 200, right? And the last chunk, which is the remaining characters of the last chunk, is shows that the length is 22. Right now, you have seen that some of the times we use create documents, and some of the times we will use split documents, right? So why do we actually use a split document? So if you are using any of the document loaders like text loader or directory loader from LangChain, so it will convert the text or the documents that are present to the LangChain document. So this LangChain document is object looks like this. So if you use a document loader to load any documents, so it will create the documents for you itself. Then you can use the split documents method to create chunks out of it. But if you are using a plain text or plain string, then you need to use this create documents to create documents which are like a LangChain document object, right? So yeah, that's the one thing which I wanted to mention. Now in this one, you can see that I have mentioned the chunk overlap. So this is kind of, you are mentioning that the last few part of my previous chunk has a overlap with the next chunk, right? So if you do a split on this, so you can see like here my last few characters are like this, right? So or updated version, so which is also present in the next chunk. So it kind of creates a continuity between the two chunks, and if at some point you need to like retrieve more chunks, then using this continuity, it can give you better results, right? So the next one is like recursive character text splitter. So if you start with this recursive character text splitter, it looks like a very complex one. Let's try to break it down so that you can understand it very easily. So the one of the good thing is that it looks into the structure of the data, and the issues which I mentioned for the character text splitter, that a word or a sentence can even be splitted into multiple chunks, that generally doesn't happen in this recursive character text splitter. So what it does is at first it tries to split based on double new lines, that is paragraphs. Then it tries to combine two paragraphs. And it checks like if the after combining two paragraphs, if the length of or the combined length is kind of less than the chunk size that has been mentioned here. And if it is not the case, then it will try to again split based on like sentences, words, and characters. We need to import this. Then you can mention like the chunk size as 500, then the chunk overlap as 0, and the length function, which I mentioned, is the Python length function, right? After that, you can like create documents. So once you create the documents, you can see like it created like 4 chunks. So in our data, if I just go back to our data, so you can see like at it has like 3 paragraphs, right? So straight away it can like split on this paragraph. Then what it will try to do is it will try to combine this paragraph to this paragraph, right? And it will check like if this combined length of this two paragraph is less than 500 or not. If it is less than 500, then it will combine these two paragraphs. Else it will just give you back one of these paragraphs, right? For the last chunk, what will happen is it will split on this whole paragraph, but the length of this whole paragraph is kind of exceeding the 500 character length that has been provided. So what it will do is then it will try to split this whole paragraph into multiple sentences, and then it will combine the sentences. Still, it does not exceed the size of 500, right? If by combining multiple sentences, still the length is not exceeding 500, so it will create a chunk based on those number of sentences, and then it will create another chunk where the length is kind of exceeding the 500, right? So if you see, as I was explaining, that will be very clear if you go through this. So at first it's creating this chunk where we can see like the length is like 393, which is less than 500. So as I mentioned, like it will try to combine these two paragraphs, but as the combined length is exceeding the 500, which is mentioned here, so it will kind of create two separate chunks for each of these paragraphs. Then it will create the third chunk, and while creating the fourth chunk, it will try to keep it as it is a paragraph, but the whole paragraph length is kind of exceeding 500. So then it will try to split the paragraph into sentences, and it will then start combining sentences, right? So till this sentence, it kind of seen that it is less than 500. Then it tried to add this sentence, this full sentence, but it was kind of exceeding the 500. So then what it did was it kind of did a split on the words, right? So by adding those extra words, it is kind of splitting on this part, and then it kind of created the last chunk, which is this, right? So I hope this is clear to you, like how this recursive character text splitter is working. So it kind of goes through each of these splitters recursively. Like first it tries to split on the paragraphs, then sentences, and then words, and then in the end it will try to split on the characters, right? So till now, whatever the text splitters we have looked into, so they are mainly like based on the character length, right? So we are yet to talk about the token length, which is very crucial in terms of like uh, the size of the maximum tokens that are allowed for the embedding model, or the context length for the LLM. Now, what we can use is we can use this split by tokens, and that will kind of take in consideration of the token length size, right? Instead of the character length, right? This URL where you will get to know like a few of the embedding models, and it's also kind of a leaderboard, so which will give you an idea like which are the embeddings that are currently performing best, and also it will tell you what are the max tokens that are supported for each of these embedding models, right? So I have kind of taken a screenshot from that leaderboard, and if I just talk about this model, like which is Cohere embedding English version 0 version 3.0, right? So there we can see that the max token is 512, right? So in case if you are planning to use this embedding model, you should not create a chunk which exceeds the 512 token length, right? So if you are creating a chunk which is exceeding the 512 token length, so it will kind of strip those tokens, and it will create embedding only using this 512 tokens, right? So this is quite crucial if you want to uh, create a chunk which is very large in size, but you also need to be mindful what is the maximum tokens that are allowed for the embedding model. So what you can do is you can like use this LangChain. You can import this TokenText Splitter where you can mention the model name. So here I have used the previous OpenAI embedding model, which is text embedding ADA 002. Now you can swap this with any of this model. So you can also mention this Cohere embedding English 3.0 model. There you need to be mindful that you should not give a chunk size which is exceeding 512. Otherwise, it will throw away a lot of tokens, which can be very important for your use case. But as the model has a limitation for the max tokens, so you should give the chunk size according to that, right? Now, if I create a chunk out of this, now you can see like the same text which we have used previously, it is creating a longer chunks. And now if I just count the number of tokens instead of the character using this function where I have used this tick tokens, and there I'm passing the embedding model, and then it will create the number of tokens based on this embedding model. So each of this embedding model has a different strategy to create tokens, and how it can it can also split individual words to multiple tokens and then create the tokens out of it. So that's why you need to pass this model, which based on that it will calculate the total number of tokens. Now I am looping through these chunks, and then we can see what are the token length for each of these chunks. So as I mentioned, the chunk size was 200. So it is creating the chunks which are less than 200, right? So you can see the first chunk was created with 200 token length, and the second chunk was created with a token length of 125. And also have to context length limitation for the LLM also, right? Because the chunks will be passed as a context during the RAG process, and that context should not exceed the maximum number of tokens which is allowed for that LLM, right? So for this model like GPT 3.5 Turbo, we can see that max number of tokens that are allowed are around 16K, right? And which recent models which are like Gemini 1.5 Pro, it has 1 million token limit, right? Or the context length, right? So you can see you can also do it in this way. You can pass the model name as the LLM model name, and similarly you can pass the chunk size, right? So it should not exceed 16K as we can see here, right? And based on that, now you can start creating the chunks out of it. So you can see here, based on the token length, it created only one chunk, and that one chunk contains the whole text, right? So last one. So far, all these approaches which we have talked about, the character text splitter, recursive character text splitter, or the token text splitter, that looks into the document structure, and it kind of calculates either the token length or the character length, and then it creates the chunk. But neither of them kind of looks into the semantic meaning of the document. RAG pipeline, your main aim is to create chunks. The chunk should not carry multiple meanings, right? So one chunk should carry only one meaning. That is one of the primary aim that you should follow whenever you are creating any RAG applications. Because if your one chunk is kind of carrying out different types of meanings, then that will not be very beneficial when you are creating an answer for the user when you're creating an answer for the user question, right? So what this semantic chunking it does actually is it kind of a time consuming process, but it will give you better results if you are taking this approach, right? So with this diagram, let me try to explain you what this is actually it's doing. Then we will look into the code. So what it is actually doing is it's creating embedding for each of the sentences that are part of your document, right? And then it's kind of also calculating the cosine distance between the two consecutive sentence, calculates the cosine distance. Then you can pass a certain threshold, and if your cosine distance is kind of crossing that threshold, then then you will ask this semantic chunk to create a new chunk, right? So you can see this is kind of a threshold which we have provided here. And if your cosine distance similarity is kind of exceeding that threshold value, then you are kind of inferring that now the sentences that are coming beyond this part are not of same meaning of this particular chunk, right? So you can see then the chunk one got created again. We can see here the cosine uh, distance is kind of exceeding the threshold, so we have created another chunk. And whenever it's exceeding the threshold value, it's creating different chunks, right? So and with this you kind of assume that each of these chunks will only carry one meaning, and that meaning would be very concise, and that will also help you to give better answer for the user question when you are doing the RAG. Do is you can use this LangChain experimental. There you can import this semantic chunker, and for this you need to have an embedding model. So I am importing this BG base embedding model. So I am initializing that embedding model, and when we are initializing this semantic chunker. So there I am passing that embedding model, and also I am kind of saying like what is the threshold type I am using here. So you can see like I am mentioning the threshold type as percentile, and I'm giving the value of this threshold as 75th. So if the cosine similarity between two corresponding sentences are exceeding this threshold value, then it will kind of create a new chunk, right? So you can see like if I create this, it has created two separate chunks using this threshold value. Now, if you are just interested on playing on this, so you can like comment out this threshold part. So if I just comment out this threshold part, we will see that it will create only one chunk. So it's as it is, you are not providing any threshold limit, so it's creating only one chunk. And if you are now giving a threshold limit of 75, it will create two chunks. Now, if you play around with this value, like if you want to be more conservative and if you want to have very specific chunks which carries a very specific meaning, you can like narrow down this value of threshold amount, and you can see like there are a lot of chunks that are getting created using this threshold value, right? So this will kind of giving you chunks which are very specific in meaning, rather than like a chunk which will have a lot of meaning in its context, right? So then the text which we were using so far was kind of only talks about transformers. So what I did was like then try to do this experiment where I try to mix two text. So one of them is like till this part it was talking about transformer. Then I have added a Wikipedia text which talks about like Article 370 of Indian Constitution. So I tried to kind of create a text which carries two meanings, and then I try to play around with this semantic chunker, right? So if I just run this, so you can see like without giving any threshold amount, it will kind of it is kind of inferring that these two chunks are very different in nature. So one of them is like transformer, and the second one is talking about the Article 370 of Indian Constitution. So you can see like even without giving any threshold percentage value or percentile value, it is kind of creating two chunks using this methodology. So I find this quite useful if you are if you want to create a better RAG. So you can straight away use this semantic chunker. But if you're not sure about, then the safer approach would be the recursive character text splitter, which kind of looks into your architecture of the data, and then it kind of creates the chunk, right? So I hope you got some understanding of the different chunking strategies that are available. And based on your use case, you can use any of these chunking strategies to improve the performance of your RAG pipeline. I will end this video. I hope you like it. Thank you. See you in the next video.